Okay, in the previous class, we have introduced the conic section functions. We have not finished it yet, but we did introduce ellipse and hyperbola. Okay, so wait, just review real quick. So we did ellipse, which is x minus h square over a square plus y minus k square over b square equals a, or we got x minus h square over b square plus y minus k square over a square equals 1. So for this one, major axis is x direction, because here we have a is bigger than b. Okay, so for this one, the major axis is vertical, like this. Okay, we'll also find out the center. We give it a center. Center for this one, for both are h and k. Okay, so we have c. We have c square equals a square minus b square, and then we have e equals c over a eccentricity. Okay, so I think we'll also have to, let me see, we can find out the center. Then we can find out the foci. Okay, foci for this one, for the first one, let me see. So for this one, the foci is going to be, for this one, they are different. This one, the foci y value don't change, so just the k. And the x value start from the center, h plus or minus c. Okay. For this one, the foci is, well, the x value won't change. X is h, but the y value is k plus or minus c. Okay, so that's for the ellipse. And then we'll also introduce the hyperbola. Hyperbola, you have hyperbola, the general form is x minus h square over a square minus y minus k square over b square equals 1. So this one, transverse axis horizontal. And for the other one, or x minus or y minus k square, my bad. Y minus k square over a square minus x minus h square b square equals 1. For this one, we have the transverse axis is horizontal. Look at this. Okay, and then we have both of them have the center for this one, center for both. Center are h and k, and for the foci, we got a c square equals a square plus b square. So for this one, foci is here and here. So we don't, maybe it's not here. It's like it's general form. So it depends on where your center is. Okay. So y value won't change, so k. X value is h plus or minus c. This is the foci. For the other one, you also have the same thing. Okay, you have foci is, some people say foci. Foci is the same word. Okay, so you have the center is here and here. So x value won't change, so h won't change, but you have k plus or minus c. And I also have an asymptote for the so asymptote is y minus k equals plus or minus b over a x minus h. Okay, this is for horizontal as this one is for the horizontal transverse. Well, it's very easy to see which one over which one. You can see is horizontal is this one. You got y minus k, you got x minus h, so put it in here. And then the other one, asymptote is y minus k equals positive negative. But the value corresponding to y is a. Change of y is a. And change of x is b. Corresponding to x is b. And x minus h. And then this one is vertical transverse axis. Okay. Alright, so both this is what I did this one in the previous class. So today we're going to look at another one. Let me see if we did this one previously. 9x squared. Okay. So we're going to look at another example before we continue move on. 9x squared minus y squared minus 36x minus 6y plus 18 equals 0. Okay. And now I would like you to try to complete a square and change this into a conic section function. I'll give you 2 minutes to try this by yourself. Okay. I think some of you probably have already finished it. Okay, are you done? Okay, I'm going to call students to work with me together. Lacey, could you please work here with me?
And so we add 4 to the x part.
Yeah, we'll add 4 here. Okay. So since I add 4 here, so what do I add here?
36 and 9.
Okay. Minus 9. Because you subtract 9 here actually. Then you have 9x minus 2 squared minus y plus 3 squared equals 9. So the function is going to be, what do we do next?
X minus 2 squared minus over 1.
Very good.
Minus y plus 3 squared over 9.
Okay. So now what is the center?
So our center is going to be negative. It's going to be 2, negative 3.
Okay. What are the vertices?
The vertices are gonna be
So is it transverse horizontal or transverse vertical? Transverse axis. The transverse axis is horizontal. So I draw the picture like here. The center is 2 and negative 3. So vertex is this one here and this one here. Okay. And the x value, this is 1. This is 1. So the vertices, the y value never change, so it's negative 3. From go 1 to negative, so it's 1. From 2, go 1 left, so it's 1. From 2, go 1 right, it's 3. Okay, vertices. So what are the foci? So first we need to find a C, right? So what you got for C? So A equals 1, B equals 3. C squared equals A squared plus B squared, so equals 10. So C equals square root of 10. Okay. Once I have C is square root of 10, now
okay, it's gonna be 2,
foci is here.
3.
You look at the foci, it has same what value? The foci, the center, have the exact same y values, right? Does it make sense, Lacey?
It's gonna be 2 plus root 10.
Mm-hmm.
Then negative 3.
Yes, and then?
And 2 minus root 10. And negative 3.
Perfect. Okay, so then the asymptote. What is asymptote?
Negative 3 minus negative 3 minus
Okay, so the asymptote, when you look at asymptote, look at this this one here. What you need to do, bring it down 1 plus 3. This one, x minus 2. Those are the two factors, right? X minus 2 at y plus 3. Bring to here, bring to here. Now, y values, positive, negative. You have two asymptote, right? Positive, negative. Y values corresponding to what value? The number on y is b is 3. Corresponding y value is 3, right? Corresponding x value is what? 1. Does that make sense? Lacey? Yes? Okay, very good. So that's the asymptote. Okay, so next one, we're going to look at the parabola. Okay. Parabola, the standard form is not a brand new thing for us. We've looked at parabola a lot. Most likely we do a lot of open upward, open downward parabola of the quadratic equation. Quadratic function is a parabola. You know that, right? So it's not a new thing for us for parabola. But we're going to look at the more general form. The standard equation of a parabola with vertex HK and the directrix y equals k minus p. Yes. X minus h square equals 4p y minus k. So for this one, x squared, so x can be positive, negative. If p is positive, it's going to be open upward. Like this, x can go negative, x can go positive, but y can only go positive if p is positive. Alright, so now, if the directrix is x equals h minus p, the equation is y minus k squared equals 4p x minus h. Okay, so basically we have this one is going to be like this. Okay, now the focus lines on the x-axis p units from the vertex. Is going to be h k plus p or h plus p k. Okay, so basically it's going to be either here. You see, if this is the vertex, so it's go up here, or from vertex go to here. So for the parabola, that is a physics application, which is if this is the directrix, if this is a parabola, okay. Now, if this is the focus and the vertex have the same distance, okay. So the vertex should be, since this is distance, it's going to be here, okay. So what it says is from the vertex, go to the function value. This distance and this distance are equal. No matter where you go to here and you go to here, this distance are always equal. This is equal distance. So from the focus point to the function value, the distance is always equal to the distance from the directrix to the function. So wherever you go, and you from this point to the directrix is always equal. This equal distance. Okay. So this is the physics application. If we remember, like then when we use this a lot in the physics, especially if you look at the car light, the front light. Let's say you put a bulb here, then I think you can get the all of the light goes this way. Okay, so go this way, it's going to be more bright like that. Okay, so put most likely we're going to put the bulb, electric light bulb in the focus point. Then you have the best light. All right, so let's look at an example and find the vertex. Focus point and the directrix. Of the parabola. Y squared equals negative 8x. Okay, I'll give you 1 minute to try it by yourself. So we first draw the picture of this one, the directrix. It's going to be, because y squared, y can be positive and negative, but x is negative 8x. So it's not going, it's open leftward. So it's open this way. So now we can see y squared equals negative 8x. There is no shift, no, so the center is going to be 0, 0. And it's open leftward, because when you say, oh, I'm not sure if it's open left or right. Well, left is negative, right is positive, because this is negative 8x. Then you know if it's upside down or left or right. Because this is y squared. Y squared means y can go positive, y negative y. But x can go one direction, either left or right. Right? So then it's pretty easy to decide which way to go. Now, vertex for this one is pretty simple. There's no shift. It's just 0, 0. When x equals 0, y equals 0. And then we can look at this. It's negative 8x. When you compare with the formula here, you always have the ratio of 4p. So you have 8. Okay. Then you always divide this by 4. You have a ratio of 4. So it's, the p is negative 8 over 4, which is negative 2. Now it's much simpler. The focus point is here. So it's going to be negative 2, 0. So the focus is negative 2, 0. And the directrix is going to be here on the other side, away from, this is the focus point, the other side is going to be directrix. Directrix is x equals, you also have the same distance too, so it's equals 2. And then I think that's it. Okay. And as I said, any point on this parabola has the same distance to the focus point and the directrix they all have exactly the same distance, have equal equivalent distance. So why is like that? I can just show you very quick. So suppose I have a point here. Suppose the point is x and y. According to the distance formula, the distance from xy to negative 2, 0. So from xy, any point xy to negative 2, 0. And what is the distance formula? I'm going to call student here. Okay, I'm going to call student here. Taylor, could you please tell me what the distance is? Give you x, y, give you negative 2, 0. Distance formula.
We're trying to find the, I don't remember exactly the point, but I know we're trying to find the, given those 2 points, like the longer value, the longer side.
Yeah, for example, I give you 3, 2, 5, 3. Can you find the distance between these 2 points?
Would it just be y2 minus y1, or no, that would be the slope. I can't remember right now.
y2 minus y1 square plus x2 minus xy square. Okay. So distance formula for this one, can you tell me the distance formula for, if I give you this, can you tell me the distance of this one? Zero minus y, or you can use y minus 0, it's fine. So it's y minus 0 square plus
Negative, or x plus 2 squared.
x plus 2 squared, perfect. Okay, so now we can, I want you to continue to help me finish this. So this is x, y is y squared, right? And FOIL this one out as
X squared plus 4x plus 4.
very good. Okay, so what is the y square according to my function? What is y square?
The negative 8x up there.
Yeah, we just substitute negative 8x plus x squared plus 4x plus 4. So you're going to have x squared, negative 8 plus 4 is negative 4x plus 4. So after I simplify this, what would this be, Taylor?
X minus 2 times x minus 2.
So it's x minus 2 squared. Square and square root cancel out, but it's a square root, it's positive. So I need to use the absolute value of x minus 2. Does that make sense? Yep. So this is the distance from this point to the focus point. Now, from this point to the directrix line, what is the distance of this one? Now, the distance of this one, since this is x equals 2, you just look at the, when you look at the distance of this way, it's always horizontal way. It's always horizontal. It's actually just the difference of x. So the x value here is just x. So the x value is 2. So the difference of x values is just 2 minus x. 2 subtract x is going to be the distance. From this point to 0 is 2. From this point to this is always horizontal. It's just a difference of x values. So it's 2 minus x. X minus 2 and 2 minus x, they are exactly the same thing. So that's why we have the distance from the function point from the point on the parabola has the same distance to the focus point and to the directrix. Okay, that's one of the property of the parabola. All right. So next, you don't have to prove this, but I just want to let you know this property of the parabola. Okay, this is the very important property of parabola. So, but you need to know in the for the mathematics, you have to know the vertex, focus point, directrix. You need to follow. You need to find out. You should be able to find those. Let's look at another example. Okay, find. Okay, find the center, focus point, directrix of x plus, wait, my bad, x minus 6 squared plus 8 y plus 7 equals 0. So I'll give you 2 minutes to work on this one by yourself. Okay, so then I'm going to call student here. I'm going to call student here. Okay, Jasper, could you please tell me what you got for this one?
Okay, so the vertex is 6, -7.
Okay, so vertex. You mean center? Oh yeah, sorry, my bad. It's just a vertex. There's no center. It's just a vertex, my bad. Yeah, just a vertex. The vertex, you do, wait. So vertex 6, -7. Then focus point.
The focus point would be 6, -9.
6, -9. So if you draw the picture, it's going to be open.
Down.
Open downward. Okay, so it's like 6, -7. It's going to be here. Okay, very good. So 6, -7. You draw the picture. It's open downward because this is x squared. X go positive negative, but it's negative y. So it's negative y. So open downward. Now this is going to be here. You can find that p is -8/4, which is -2. So from this one down 2 units. So it's -7. Down 2 units, so it's -9. So what is the directrix? Wait, is what?
-2.
What equals -2? Oh, the p equals -2. Directrix is a line. Like it's going to be here.
X is -2.
Okay, so no, it's not -2. For the example, this is 1. This is y equals 1, right? So directrix is this line here. This line here is the directrix. So the y equals something.
Y is -2.
Y is -2. Why is negative 2? Negative 2 is just a p-value. P is negative 2. It does not mean y is negative 2. Start from the vertex, go up 2 units. So this is 2 units. This is 2 units. So go down 2 units is negative 9. Go up 2 units.
Negative 5.
So what equals negative 5?
Y equals negative 5.
Perfect. Okay. Y equals negative 5 is the directrix. And then this is the vertex focus point directrix. That's enough. Okay. So now next thing we need to do is, if I give you something, for example, find the equation of the parabola given the vertex. I give you the vertex 5 and 4. I also give you the focus point is 3 and 4. So now, can you tell me the equation of the parabola? I give you 1 minute to work on this one. Okay, so I think I'm going to call a student to help me with this one. Alright, so Matthew, could you please tell me what you got for this?
Well, I'm still kind of working on it, but I know that, what's it called, the directrix, or no, yeah, the directrix is it negative, or not negative 2, is it 2?
Yeah. So I think the first thing we do, we can graph it. Vertex is 5, 4, so it's going to be here. Focus is 3, 4, is here. So now you tell me, this is the vertex, this is the focus point. Wait, 3, 4, right? 3, 4 is going to be, this is 5, 4. So 3, 4 is going to be this one here. It's going to, the same y values, but this is the focus point. So focus point is here. This is the vertex. Can you tell me if it's open upward, leftward, downward, or right? Open left or open right?
Right.
Open left, yes, because the vertex inside of the parabola is open this way. So now, I think it's pretty simple to write down equation at first. You know that a vertex is 5, 4, so it's y minus 4, right? Then x minus 5. Now, since it's open left means x is negative, y can go positive and negative. So it's going to be y minus 4 squared. And it's open left, so it's negative x direction, right? So x is negative, so it's negative x. So negative x minus 5 equals. Well, the thing is we don't know what is that coefficient in front of here. That's the last thing we need to find. Since we know the distance from 5 to 3 is 2. The distance is 2. So now, what number should I write here, Matthew?
Would it be
P equals 2. What did I write here?
wait, not 8. Would it be just 2? Or no, it'd be 4, so it'd be 1/2.
No, it's 8. You got it right. -8. Because it's look at this. It's 4p. It's 4p. 4py times that. Okay, so it's 4 distance times 4. If this is distance is 2, so this is the 8. So it's -8. So now we're done with this. Okay. All right. So one more example. Now everyone try it. Find the equation. It's the same thing. Okay. Find the equation given vertex 0, 5, given directrix y equals -3. Okay, find the equation. You're welcome on this one, everyone. Okay, so the equation is going to be, I would like a student work with me together. So, and tell me how you got it. Travis, could you please tell me how you got it?
So when you graph it, it's going to be an upward facing parabola at 0 to 5.
Okay.
And then the directrix is below it at y equals -3.
Mm-hmm.
So from that I got p equals -8. And then the equation would be x squared equals -32.
-32?
Y minus 5.
Okay, and just want to, no, this is open upward, right? It's positive y or negative y?
Positive.
Positive y, so it's positive 32. And that is right. So this is like this. Does it make sense? Yes? Okay. The reason I don't want to confuse you because I make it simple for you to memorize. If it's open, if it's positive y, it's positive number here. If it's negative y values, it's negative y here. Negative value here. Why is like that? Because x squared is always positive. Because y is positive, the number here should be positive. If you open downward, x squared is always positive. If y is negative, the number here should be negative. Otherwise, you don't have positive numbers. Okay, that's how you to memorize. That's how you can memorize this number here. Is a positive number or negative number? It's going to be 4 times the distance, whatever distance is, but it's positive because it's a positive y value, and this is positive. Y is positive, so this number has to be positive. If it's negative, you will have a positive equals negative. Positive, positive. This is positive. This y is negative. This is negative as well. Okay, so that's how you can easily memorize this. So next example, not find the parabola, find the hyperbola. Find equation of hyperbola. Okay, so vertex, not vertex, actually vertices. You have two different vertices, 2 plus or minus 3. Okay, and then foci is 2 plus or minus 5. Okay, so I would like to ask the student work with me together. So Joshua, could you please work with me together? Okay, so first I give you 4 vertices is 2 plus or minus 3. Can you tell me what the center is? 2, 0, perfect. Once I have the center, you see is if I draw the picture 2 positive 3 to negative 3, so it's going to be a transverse axis is the vertical. So now I write as y minus 0. The other one is x minus 2 square minus, right? Because y is the open, this is the transverse axis vertical. Because you draw the picture 2, 3 to negative 3, x never change. So if you draw the picture, it's like this. Now you got the center is 0, y is 0, x is 2. So I need to find these two numbers, the denominator of these two. So okay.
What you can from there is the y value of the foci is plus or minus 5. So you can say that c squared is equal to 25, and then solve for a and b from there.
All right. So now I think you can tell me what is a.
16.
Y is 16.
A is 4.
No. Wait. Y is 4 because this is 2, 3, 2, 2, 3, 2, 0. This is a 3.
Okay, it's 9.
9. Very good. So this one. That would be 16. Perfect. Okay. Since c squared equals a squared plus b squared, because I got a squared equals 9, so c squared is 25. Together, I can got b squared equals 16. Got this. Okay. So that's how can you write the equation of a hyperbola. I think we are done with 10.1, and